In this question we have a function f, which is in terms of two variables, x and y. So it's given here by the square root of x squared plus y squared. And in turn, x is a function of t, namely x of t is ln t. And y is also a function of t. Y is equal to t squared plus t. And what they would like to have us calculate is the rate of change of f with respect to the variable t when specifically t equals 1. So we're going to need to use the chain rule here, because what they're asking for is how fast is f changing with respect to t, but we can only get to the variable t by going through x and y. So we need the chain rule in this question here. So let's write down the formula for the chain rule. The derivative of f with respect to t is equal to the partial derivative of f with respect to x times the derivative of x with respect to t. So if you look at this part here, this is how fast is f changing with respect to x multiplied by how fast is x itself changing with respect to t. When you multiply these two things together, you get how fast f is changing with respect to t through x or via x. So this is how much x, the x variable, essentially contributes to the change of f with respect to t. And we do the same thing with y, because of course f depends on y and x. So this is the partial derivative of f with respect to y times the derivative of y with respect to t. So again, this term here is the contribution to the change in f with respect to t, but via y. So this is how much y essentially contributes to this change here. So we can go ahead and actually calculate these. The derivative of f with respect to x, so we're going to take the derivative of the square root of x squared plus y squared with respect to x, and this is 1 over the square root of x squared plus y squared. And the way you calculate that, times x. The way you calculate that is change this into x squared plus y squared, all to the power of 1/2. So change the square root into an exponent. And what you'll find is the exponent comes down, and you end up with this equation here. The derivative of x with respect to t is 1 over t, because the derivative of ln t with respect to t is just 1 over t. Plus, same kind of thing here, the derivative of f with respect to y looks pretty much exactly like the derivative of f with respect to x, only we have a y in the numerator. And then the derivative of y with respect to t, this is going to be 2t plus 1. Okay. So now we're in a position where we have, this is the derivative of f with respect to t, but they would like this to be calculated at a specific point, namely when t equals 1. So we definitely can go ahead and wherever we see a t, we can sub in 1. But we're still going to have these x's and y's kind of in our derivative, and that's not great. So what we need to do is we need to figure out what the actual value of x and y are when t equals 1. So when t equals 1, x is equal to ln 1. We've substituted in t equals 1 into x, and of course that's 0. And y is equal to, when we sub in t equals 1 into y, we get 1 squared plus 1. Y is equal to 1 squared plus 1, which is equal to 2. So because they want this derivative specifically when t equals 1, they're also saying that they would like this derivative when x equals 0 and y equals 2, because that's what x equals and y equals when t equals 1. So now we have all the things we need to plug in here. So df by dt at, say, t equals 1 is sub in x, so we get 0 over square root of 0 squared plus 2 squared times 1 over 1. Sub in t equals 1 plus y here is 2 divided by the square root of 0 squared plus 2 squared times, sub in t equals 1 into this, 2 times 1 plus 1. Of course, this 0 in the numerator here wipes everything out in the first term, so this is just a big 0 here. And this is 2 divided by the square root of 4, which is 2 divided by 2, so that's just 1. So this becomes 1 times, and inside the brackets here we have 2 times 1, which is 2, plus 1 is 3. So we have 1 times 3. So this answer is just 3. So this is the how fast f is changing with respect to t, specifically at the time t equals 1.